The human quest for knowledge never ceases, especially at Bosch, where each one of us is driven by the desire to develop technology with a specific aim of making mobility clean, safe, and economical. Our Research and Development Department is focused on developing products that touch and affect life positively. Research that leads to machines which can make the world a better place to be. Knowing the cost-effective advantages of diesel, way back in 1927, Bosch started producing injection pumps for commercial vehicle diesel engines, and in 1936 for passenger car diesel engines. Now, for over 75 years, Bosch has been on the path of improving diesel injection technology so that vehicles can be cost-effective and fuel-efficient, more comfortable and responsive, and very environment-friendly. Though diesel technology was known for its reliability, longevity, and economy, it was still not becoming very popular in the passenger car segment. The direct injection technology did make a considerable contribution in largely addressing these concerns of the diesel engine, and brought in a major change in the way diesel vehicles were driven and accepted, especially in the passenger car segment. But as Euro norms were becoming more stringent at every level, a further improved solution was required for the diesel engine to have lower emissions and noise levels and yet deliver higher torque. And this technology has again been developed by Bosch. The Common Rail Fuel Injection System. This is how a common rail injection system looks. The entire system can be broadly divided into two segments, the low pressure and the high pressure delivery area. The pre-supply pump draws fuel from the tank and sends it to the fuel filter, which cleans the fuel before it reaches the high-pressure pump. The high-pressure pump is the interface between the low and high-pressure stages. In all operating conditions, it is responsible for providing adequate high-pressure fuel. From here on, the fuel will travel in a completely high-pressure delivery system. The high-pressure pump pressurizes the diesel fuel to a system pressure of up to 1600 bar and passes it through a high-pressure line into the rail, which is a high-pressure fuel accumulator. In contrast to conventional systems, the fuel in the common rail system does not need to be specially compressed for each individual injection process, as the high-pressure fuel pump keeps the pressure in the system almost constant. The inherent elasticity of the diesel fuel generates an accumulator effect in this rail. This property of the fuel, combined with constant input from the pump, keeps the pressure inside the rail almost constant, even after small quantities of fuel are passed out from the rail into the injectors. This high-pressure accumulator, or rail, is common to all the cylinders, and so it derives the name common rail. And it's this common rail which ensures that the injection pressure remains constant from the moment the injector opens till the spray is complete. A high-pressure fuel line delivers diesel to the injector, which in turn has to inject the fuel directly into the engine's combustion chamber. The injector's operation can be divided into 4 states. In the at-rest state, the solenoid valve is not energized and is therefore closed. The second state is the opening of the nozzle to begin injection. When the solenoid valve is energized with the pickup current, it opens the bleed orifice by moving the armature. This begins the flow of fuel from the valve control chamber, ultimately reaching the nozzle, opening the needle, and beginning the injection. The third state is the state of injection. Once the nozzle is opened, fuel is injected into the combustion chamber at a pressure almost equal to that in the common rail. And during the entire process of injection, the pressure is maintained. The fourth state is the closing of the injector. As soon as the solenoid valve is de-energized, the valve spring forces the armature downwards, and the ball closes the bleed orifice, which ultimately causes the closure of the nozzle needle. This ceases the injection. The brain of the common rail system is the electronic diesel control. The electronic diesel control is comprised of three major system blocks. First, the sensors and set point generators for registration of the operating conditions and the desired values, which is required to preset a variety of physical parameters into electrical signals. Second is the ECU, which generates the electrical output signals by processing the information using control algorithms. And third is the actuators that convert the ECU's electrical output signals into mechanical parameters. Let's now look at the system's advantages. The merits of the common rail system over any of its predecessors are various, and this is clearly a new generation in the fuel injection technology. To begin, we can address the issue of high noise levels of earlier diesel engines. Combustion chambers in diesel engines are extremely high-pressure areas, as diesel needs to be sprayed and compressed until it ignites. This excessive pressure in the combustion chamber is the basic cause of high noise levels in a diesel engine. The common rail system has the capacity of doing what is known as a pilot injection. A pilot injection is a small amount of fuel injected into the cylinder to precondition the combustion chamber. This pilot injection leads to a partial combustion, which causes a reduced ignition delay and lower combustion pressure rate. The result is a smoother combustion and lower engine noise. The difference in noise is demonstrated here on a Mahindra Scorpio with and without the common rail system, which clearly indicates how silent an engine is made with the common rail system and its pilot injection. The common rail system, which delivers high injection pressure at lower engine speeds and makes the vehicle robust and responsive. A very important feature, especially for passenger cars. And finally, and very importantly, the environmental concern. Older diesel engines are known for high particulate emissions and also NOx emissions. The common rail system has taken into consideration these factors and counters them with a post-injection, which is applied when introducing regenerative-type particulate filters. The increase in NOx due to high injection pressure is controlled by introducing continuous exhaust gas recirculation by the ECU. This results in a much cleaner diesel engine, which is extremely environment-friendly and matches the latest Euro norms. The common rail system has clearly brought diesel injection technology to its best limits as of today. It has aided consumption of cost-effective and efficient diesel fuel in applications like passenger cars, where it was rejected in the past. It has brought in the fun and pleasure that was missing in driving a diesel vehicle, and has considerably reduced harmful emissions while retaining fuel efficiency. The common rail system, a new generation in diesel technology, the future of automobiles around the world, and a complement to the global commitment of Bosch to make mobility clean, safe, and economical.
Our research and development of the common rail system in India is fueled by two factors. First, the specific requirements of the growing Indian automobile industry. And second, the world-class technology in Bosch for the like of Mercedes-Benz, BMW, Hyundai and other leading car manufacturers of the world. The success of the Scorpio Common Rail project is the result of the state-of-the-art technology and dedication of our engineers.
We in India are now ready to manufacture the challenging, high-precision components of this high-pressure fuel injection system with a strong commitment to this modern technology. Extreme care is being taken to set up state-of-the-art production facilities where this new generation of truly world-class common rail components will be produced.
The Indian automobile customer is becoming very demanding in the availability of latest technologies. The customer would like to have diesel vehicles which have high torque, are economical and fun to drive. Bosch has a 65% market share in the world automobile industry in the common rail systems. We at Micro Bosch are equipped to produce the technology locally with the same global quality of Bosch.
The Common Rail System. Get ready for it.